much, Dr. Enarupe and colleagues for inviting us to participate in your working group meeting. I was just mentioning to Tim at the top of the call that I remember when Tim and Biplov presented last year to different West African colleagues about the work of the SERVIR networks geospatial AI working group. Last year it might have been still called the TensorFlow working group, and it's really great to see how you have taken it and run with it. And by the way, I don't know if Josh has started the recording yet.
Josh, are you starting recording?
Yes.
Hello, Josh.
Hello, yes, I have.
Okay, thank you.
All right, because I don't see anything about recording, but that's fine. So I guess just to kick it off, again, I was pleasantly surprised when Gloria asked if a while back if I might be able to speak to the working group, and I guess we just wanted to share some of the things that that I specifically been working on. I've just started to kind of dive into some of this deep learning stuff, even though I've been I guess on the outskirts of it or aware of it since the SERVIR TensorFlow working group started just over 5 years ago. And by the way, also welcome to Phoebe, our continental coordinator for Africa. And so I guess with that, I'll just dive in. And so I think that Tim and Phoebe and Jacob and others would kind of agree with, I think one of the challenges that we see across the broader SERVIR network is, we see people who have done a lot in terms of, traditional machine learning, but maybe not, fully exploiting or starting to exploit deep learning in different SERVIR services and workflows. And so it's kind of the question we ask ourselves is kind of why not? And then with this presentation, I'm proposing, one way in which I think that, as a group that we could start to, take more advantage of it. And of course, again, if there, I'm sure that there are already people who are, taking these in different directions as a part of the broader SERVIR GeoAI working group. About a month ago, we had a really great presentation from Dr. Modou Mabai, who is, no stranger to the network, who's based in Senegal, who presented on how he's, over the last 5 years, over the last half decade, really run with what he was introduced to at the TensorFlow Exchange back in 2019. And I felt really humbled and impressed by that kind of work. And so I hope that the Uncle Sam meme, maybe means the similar thing for you in West Africa. But we have this Uncle Sam here in the U.S. kind of saying, "Hey, we need you." And what does he need us to do? Well, he needs us to start implementing deep learning into our different workflows and services. And I know that when Phoebe shared with us the SERVIR West Africa work plan, when all of you met in Sali, Senegal, late in August, I do think that more deep learning was integrated into the different activities. We know that on the SERVIR side, deep learning workflows have been started to be implemented for specific services. Nonetheless, say, hey, we want you to do deep learning, but the question still is how. And so just to say over the next, little bit, and again, I promise to go really quickly, just in terms of a general outline of what I'll be talking about. And again, I promise I'll try to be quick. Some objectives, what kind of software, how that's installed, and then, some really simple steps that the ArcGIS has kind of laid out. And I guess if it's not super clear, or hopefully it'll be clear as I talk about it, just one of the things that impresses me about ArcGIS, specifically the platform, they've kind of really made an end-to-end workflow that somebody could implement, deep learning for different types of things. Specifically, I'll be talking to you about land cover classification. I know that, Dr. Enarupe, I know that Phoebe and others, Jacob, Tim, etc., all people who've, worked with land cover classifications. And so, something that we're already doing, something that's relevant to the work of the West Africa Land Cover Task Force. And so why not, look at deep learning for land cover classification, and then just some of the additional tools that are there, and then for some future works, etc. Again, we have Tim, Phoebe, Jacob on here. Tim, I know, has some specific thoughts about, network-wide strategies and things that are coming like this, applied deep learning book that Tim, Biplav, and others are leading. That all said, for the next 15, 20 minutes or so, just like to talk to you about how you can, using ArcGIS Pro version 3.3, implement a deep learning based land cover classification. Also, kind of look at some of the small challenges you might encounter if you haven't already kind of dived into this, and also some of the best practices I see as to get the classification to work the way you want it to work. Because long story short, you can go with some default options and they'll kind of take you down a road that maybe you don't want to go. So I guess I realize also from querying Glory before speaking about this, that maybe not everybody already has access to ArcGIS Pro, and so I hope this does not become a barrier to entry for people. I will also though mention at the very end, I highlight that there seems to be similar workflows using QGIS for doing some of this stuff. So again, I think everybody's familiar that there are a lot of things that you might one thing that works in ArcGIS Pro, there might be a really similar workflow for QGIS. Nonetheless, you need to have ArcGIS Pro, and you also need to have these deep learning libraries for ArcGIS installed. And the long and the short is that it installs packages for PyTorch and TensorFlow with Keras. And so I know that, again, these are kind of like the standard, I guess, libraries that people use, including people who are using things, outside of desktop GIS, like, again, the work that Tim and others have pushed in terms of working with Google Earth Engine and TensorFlow, et cetera. So again, if you're already working in that world, you're familiar with this stuff. Just to say, in terms of installing the frameworks for ArcGIS, there's a GitHub page where you can find the different packages for grabbing these and installing them. And once again, you already have ArcGIS Pro and you're able to install these packages. It's quick after that. So in terms of what the overall process looks like, and interesting to say that I remember 5 years ago, and this is something that's on the Servir TensorFlow working group webpage, but Tim had put together, for instance, a kind of diagram showing the different connections between how TensorFlow connects with Earth Engine, et cetera, and kind of like a step-by-step for how the process works. Well, for ArcGIS, I've kind of simplified, just showing what that process looks like. For those who have done traditional supervised and non-supervised classifications, the workflow is somewhat similar in terms of say first step really is having training data if you're doing supervised classification, and so of course that might take a little while. But once you have that training data, then there are 3 steps, and I'll kind of walk you through what the toolbox looks like. But you have to export your training data into a format that these deep learning based classifiers can use. You then need to train your model, and then you need to, what I guess the people in the deep learning world, like Tim and others, called inferencing, which is classification. And I've kind of highlighted, using a standard laptop that doesn't have an additional GPU. It doesn't have a GPU. Exporting the training data might take a few minutes. Training the model might take a few hours, and then doing the inferencing or doing the classification might take 30 minutes. So overall, if we already had training data, this whole process might take maybe between 2 to 3.5, 4 hours to run, which isn't that incredible. And then I guess for the examples that I'm going to show here, just quickly to mention, I'm going to present examples based on Belize. It's a small country, 23,000 square kilometers. It's not in West Africa, but it's a really small area. I'm going to use Landsat 9 data from 2023, as well as training data that I've pre-collected. I had resampled the data originally from 30 meters to 100 meters to see if that could help in speeding up this deep learning workflow. But of course, some of the things that I'm going to show, I believe, can be applied to any other places as well. So that all said, if you have ArcGIS Pro open, there's a toolbox called Image Analyst, which unfortunately, also I should mention, you will need a specific license for, which is, in addition to, regular things like spatial analyst or geostatistical analyst. Without those, then, you won't be able to use the deep learning based tools. But again, as mentioned, I know that there are, other approaches using other types of software. So again, I hope that this isn't a barrier for moving forward. When you do have the image analysis extension open, or the toolbox open, On the deep learning, you're going to see multiple things. I wish Esri had maybe better labeled these things to kind of make it into more of like a workflow. But there is that step there, or tool that says export training data for deep learning. There's another tool that says train deep learning model, and the other one that says classify pixels for deep learning. And of course, these are the specific things that you need for land cover classification. But of course, if you're looking at other types of things like object detection, then it would be using different tools. Like there's the classify objects instead of classify pixels, which is more for wall-to-wall classification. So step one, exporting the training data, fairly simple. Again, there's that tool there. Let's say you have your polygons. It can also accept data in raster format. However, you will, in addition to your training polygons, need the input imagery that it's going to train off of. So, you're able to then also select an output folder where this data, when you've generated in that specific format, where it's going to go to. Again, this either a raster or a shapefile. In this case, I'm using a shapefile, and then my mosaic from 2023, which I've resampled to 100 meters. And of course, having the data in shapefile format, it has a field that I've created called class. And in this case, kind of you can see from the naming of the file, I have 10 specific classes that I have the data in. And again, you can see I have training data for the most part spread across the country. And then the other thing I wanted to mention, just again, showing what that is. And for the specific training data, and I've had the chance afterwards to talk to, Tim, Biplav, Kel, Nick Clinton, and other people about some of this process, also Ujjwal Gandhi. I think one thing that Kel was noting is somewhat different from, using TensorFlow with Earth Engine is in the case of ArcGIS, it seems each of your polygons needs to be one specific land cover class. And so it's not accepting, I guess, multi-class polygons. So one thing to recognize. And I guess one other thing as well, by default, ArcGIS is going to generate samples where your tile size is 256 pixels by 256 pixels with a stride of 128 by 128. And so that's something that we're going to have to also take into consideration. Nonetheless, when you're in this set of options or whatever, by default, this ArcGIS tool picks a specific metadata format for you called Pascal Visual Object Classes. And unfortunately, and this is something that's come up it's actually a technical issue on the Esri page that they've noted. If you go with just the default of the Pascal Visual Objects classes, then you will not be able to perform a land cover classification. And so the fix then is from there, you just basically pick, you go from Pascal Visual Objects to classified tiles. So you've selected your input satellite imagery, your input training data, given it the classification field. Hopefully you've also changed here the size of your tiles as appropriate. And you also specify that, you have to, base that on classified tiles. But of course, then the other issue I mentioned before, previously when I actually was using data that was 500 meters in this attempt to make things run really quick. When I did that, and again, using a default patch size of 256 by 256 pixels, what I realized when afterwards I was able to see the exported training data was that it was generating, tiles that were 128 kilometers by 128 kilometers, meaning I was picking these large patches which represented everything and not necessarily pure pixels. And so this is something that afterwards I had to remedy by then, I decided to go from 500 meter data to 100 meter data. And then by doing that, I then had to pick a smaller tile size of 10 by 10 so that then it was, 1 kilometer patches where essentially everything in that 1 kilometer patch pertained to only one class. And that was the fix that I had to do. That's what that looks like. And then I was able, again, pretty quickly, in this case, in like 1 minute, able to generate my tiles. The next step after you're able to generate your tiles is actually training the model. And I'll just also say that I guess this is the part that takes the longest and also a part that I think you need to put a lot of attention to in ArcGIS. And probably similar if you're working with, again, TensorFlow and Colab, and with Earth Engine, etc. All these different parameters that you have to take a look at. But as a default, this is what the tool looks like. And of course, you're going to want to input the training data that you've generated in this specific format. give an output folder where you're going to put stuff, where you're going to save the data rather to. And then this also gives this epochs, or I guess the number of runs that it's going to do and redo, et cetera, et cetera. And then Esri themselves, they explain specifically what the epoch is. Says, the max epoch is when, where the data sets fast forward and backward through a neural network of one. If it's, if you listed the one, they talked about, the recommendation is that you test up to maybe 100 times or so. In my case, I found that setting up to 50 epochs is useful. And then the other one is there's an advanced tab there for looking at this as well. And under the advanced tab is where they, above the advanced tab, of course, is the model type. Him and others, who've done this stuff routinely, would probably say that I guess the recommended type, or a lot of folks are using UNets in terms of how they're doing their neural network. However, in addition to that, Esri will ask you for what's called a backbone model, and there are multiple examples and options there. When you click down, well, of course, for your model type, they give you multiple different types for your model type. And then for the backbone model, there are also many options that are, I guess, pulling from things which are in TensorFlow and pulling from things which are in PyTorch. If I'm saying anything that is like completely wrong, Tim, others, please feel free to jump in. That also said, though, on the Esri webpage, and afterwards I have links for this, they do have more information about these different backbone models, how they've been trained, how these architectures have been configured. Yeah. And welcome, Kidia. That said, for instance, in this case, I had picked a UNet with a ResNet 18 as the backbone model, and on a standard laptop without a GPU, I was able to do the model training in a little over an hour. And of course, Esri, when your process finishes, for this process, for the previous process, for the other process, it'll, give you this neat little, note that contains the different options that you had picked. Here's another option where, in this case, with 20 epochs, it took 1 hour. In this case of 50 epochs, it took the run up to just over 2 hours. So again, the UNet architecture, 50 epochs, backbone model of ResNet 18. And then, of course, one other thing that in the last, say, month and a half that I've been doing is I've been testing different backbone models and kind of also seeing what the impact on the time it's taken to do that, as well as the performance in terms of what it looks like. I've also, switched from just using UNets to some of the other model type architectures that are there, like DeepLab version 3, etc., and also other backbone models. And in just a little bit, I'll kind of show you what that looks like. But I guess after you've trained your model, then you can proceed to the next step of doing what's the pixel-based classification or inferencing. And again, all you have to do then is pick your input raster, which are your original satellite image that you're looking to classify, and your model that you've trained. And so in this case, again, I have my 100-meter Landsat mosaic. I have inputted the model that I have generated earlier, and then of course I give an output raster based on the input satellite image. And in this case, I haven't messed around with any of their default options for the arguments there. And I find that doing the classification itself at 100 meters has taken roughly about 29, 30 minutes. And so yeah, and of course, having after you've run your model, the other thing is to understand what it's done and see what the outputs look like. And so I've just included here a few additional slides that I'm going to run through quickly. Esri provides tools for looking at model performance, and so again, you have your image analyst extension there. Under imagery tab, there's another one called deep learning tools, and it has review deep learning models. And here's where you're able to input that model that you've generated and start to look at training and validation losses. And again, I know that Tim and others who've been working on this for many more years than I have can provide additional inputs on that. But the general idea that when you're running this, it's separating your data, your training data out into essentially 3 batches. And again, Tim and others, please correct me. You have your training batch, your testing batch, your validation batch of data, or it's kind of splitting your different data, and then it's kind of seeing what after the different the number of epochs, et cetera, how your training is matching up. And of course, you have this initial accuracy that when you just started running the model to when the model stops. In this case, I had 20 epochs I was running it at. Started with an accuracy of say under 70%, and then ended at around 74.5. And again, ResNet 18 backbone model, we're using the ResNet 34. We see that the overall pattern of training and validation looks different. And I've heard from Tim and Kel and others that, long story short, you can use these graphics to see if your model say didn't do as well. And I think what they were saying is, and again, Tim, feel free to jump in. I think they were saying you want more or less for your validation lines essentially to kind of go along with your training lines and not have things that look kind of like this. Where again, you see, Tim, please jump in.
Yeah, I mean, you're totally right. And the interesting element here too is that the way these models work is you are creating individual batches. You can specify a batch number, or sometimes referred to as mini batches, and they're a portion of the training data that's fed to the model. So as it moves across the network from your input to your output, which is a known state, what the classification is, you've given it a label. The way the network works is it does back propagation. It looks at that endpoint and says, oh, I've identified this as the specified labeled land cover. Let me learn the weight of this by going backwards and applying that weight to each of the nodes. So essentially it learns by each of the batches that it's given. But then, because you've got a lot of data, you can replicate this over all of the data, and that's what's called the epoch. So you want to have your training, which is essentially all the data that you ever give to it, incorporated within these batches, but also over all epochs to eventually converge with your validation, which is completely independent. It allows you to better understand how generalizable your model is. If it's given new data, can it actually identify it? That's the skill of your model.
Awesome. Thank you so much, Tim. And I guess again, as really appreciate that explanation. As Tim is getting at, you essentially want your training runs and your validation runs to converge, which in some cases, depending on, at least for the data I'm using, and could probably come out differently if you're using different data for different places, etc. I do find changing the backbone model as well as the model type, the architecture, does implement what I'm seeing. That all said, just in the interest of time and to kind of open this up for discussion, the other thing as well. So one thing is reviewing the actual model performance using this tool that ArcGIS provides. Review the deep learning models. The other one is, I guess we have the saying in English that the proof of the pudding, or at least in my country, we modify the saying and we say the proof of the pudding is in the eating. And the other one is, you have your result. And again, this very first run, or one of the first runs, the UNet with ResNet 18 and 20 epochs, I'm able to look at the output and I say, all right, red's so green is forest, red is urban areas, light green over here is wetland, dark blue is ocean or whatever. Overall, this model actually looks fairly good, except maybe we don't have that many urban areas or settlements across the country. When I with the same model, I ran it up to 50 epochs. Now this one actually looks, say, in my opinion, not as good as the previous run. This other run with ResNet 34 actually, to me, looks a little bit better than with ResNet 18. And of course, Tim and others can get into the difference between the different backbone models that are being used. But now when I've tried with, instead of a UNet, I tried with Deep Lab version 3 and ResNet 18. This one, to me, seems like it's really overrepresenting urban areas at the extent of everything else. And so I say, this model maybe not so great. This other one, instead of ResNet, I'm using what's called MobileNet. And what I read from the Esri documentation, supposedly these MobileNet models are developed to run on even said supposedly run on edge computing, so on things like cell phones, tablets, etc. And so supposedly they consume less energy. I found that the time it took still took around similar amount of time, but the output visually looked fairly good compared to the other ones. And so I thought, this one looks pretty good. Another mobile net model. So if this one was version 2 with, I guess, 100 layers, I believe, and can correct me. But in this one, version 3, this one like really, really doesn't look that good. And so again, just by doing some of these experiments, I'm getting a feel for what seems to be working, what seems to be not working, and then taking a page from the playbook of this intercomparison work that Phoebe and Tim and Jacob and Glory and others have been involved with, earlier in Servir. I basically put together this huge table, Google Sheet, where I've started documenting every time I do a run, how long it takes to do the run, what's the accuracy, how many epochs it takes, and then also, when I do the inferencing, or if I've done the inferencing, what the output looks like, which one looks, qualitatively better, et cetera, et cetera. I'll try to wrap up, but just by saying, for instance, in this earlier one where, I mentioned at the very beginning when I just started doing this stuff, back in August, when I started using these, what I call inappropriate outputs, where when I was picking tile sizes of 256 pixels by 256 pixels, which are basically creating, tiles that were like the whole, half of the country and not these pure pixel samples, what happened? I also got, results that, again, from this graphic, don't look great. However, it did say that the overall accuracy was, 99.9%, which, I think is kind of questionable. But when I looked at the output, everything was, most of it was like one class. And so however, I think over some of the training areas, it did pick up just the little training areas correct. And so I think it's what we term as overfitting. And so, yeah, what did I learn from the exercise? That you do need to kind of tweak the input parameters. I think part of it is looking at your outputs when you actually run the stuff, the classifications, seeing if they look good or not. And so with that, wrapping up, I'll pass over to Tim in just a moment. But I think for me, again, in the recent past, I just started to, experiment with some of the stuff. What have we learned? I think if anything, the lesson that I'd like to share with, our West African colleagues is that deep learning doesn't have to be unattainable. Of course, if folks don't have access to ArcGIS and don't have access to the image analyst in ArcGIS, then I guess it is somewhat unattainable. But again, I'll just quickly show the QGIS plugins that exist. But again, the fact that you have a working group for looking at machine learning and deep learning and AI, again, doesn't have to be unattainable. In summary, with ArcGIS Pro, it's possible to execute this classification in just 3 steps. You will need to have these libraries installed. You will need to properly select your parameters. But of course, I'm sure that this kind of lesson goes for any, if you're also doing this stuff outside of ArcGIS or in any other environment. There are only 3 steps. You export your data into a format that can be ingested. You train the model, you do your classification. And again, my observation has been that if you work with the default parameters, which might not be designed for classification per se, but maybe for object detection, then a classification won't work. If you have a standard laptop that doesn't have a GPU, you can do this workflow in 3 or 4 hours. And of course, just to also mention that ArcGIS provides these additional tools for kind of looking at your model performance and your outputs. Future work, of course, just saying, hey, if you're able to take this, implement it for another part of the world, say Ghana, Nigeria, wherever you're working. And of course, Tim and others are kind of the evangelists for cloud-based options, leveraging TensorFlow, Vertex AI, Earth Engine, Colab, etc. And there's also, I'd say, additional stuff you can read on. Phoebe, jump in.
Sorry, I don't know if Tim's presentation is on the same thing, or we can go ahead and ask you questions before Tim comes in.
Well, I was just going to tee up a few slides for Tim to also talk about the broader work of the Servir working group, including the applied deep learning work that they were doing. So I don't know if you want to ask a question, or Tim, you want to mention the deep learning work applied book.
I'll just hop in real quick and just mention that within SCO, as you all know, there's been a big push over the last few years in developing these knowledge products that are driven from the hubs, driven from the Science Coordination Office on identifying needs within the network and also providing back to the scientific community. So highlighting here the SAR handbook, which Emil was deeply involved on, and that really addressed a very specific need. How can you use SAR for forestry? Very practitioner focused, giving the lessons on walking through all the different elements of how you would use a broad set of SAR to address these forestry activities. So within the GeoAI working group, we're modeling that same idea in creating these knowledge products around deep learning, because we know there's a very steep learning curve in getting into deep learning, especially in an applied sense, because again, you can use standard models and go forward, but how do you address a particular question? So since we've been working now since 2019 in this working group, our intention here is to start taking steps in providing products back to the community that folks can contribute to, they can work towards in developing specific content, and also refer back to over the years. Even though this field is moving very fast, it still allows opportunity for folks to have like a definitive approach for crop mapping, for instance, or addressing flooding. Here's 5 examples of that. So the idea here is to really be practitioner focused and building capacity with applied examples of deep learning. So we're in the early stages of this book. We have 15 authors right now who are contributing chapters for a broad, they're addressing all of the severe thematic areas, and they're specifically addressing use cases within the applied deep learning landscape. So that would include things as object detection or semantic segmentation or data fusion, areas where you would want to use deep learning, where maybe I'm glad Emil shared this, because this is an active area that we are working in, and it's open to everyone. It's open to folks at Severe West Africa and also just other academic colleagues as well. I know we have ASTs working on this as well. And in particular, there is a group that was interested in working on the artisanal mining as an example as well, because I know that's been an area that has been a space where there has been a lot of deep learning work in the past as well. So just wanted to highlight that as a motivation of sort of a larger year-plus activity that's happening with the GeoAI working group. And I've also put these comments just for awareness for everybody in the work plan as well. So people know that these activities are happening, because I know there's this is sort of a global initiative, and it's nice to connect with this working group in particular and share these opportunities. Emil, I don't know if you've got another slide.
I do in 2 slides. So let me just jump forward just to say, of course, everybody's going to have the links to these slides. There's additional stuff. One of the things that I also linked, though, is we talked about this. Tim and others have, led this GeoAI working group that's been active since 2019 for over 5 years. You are more than also welcome to participate in those meetings. Let me also tee that up a little bit. And then I'll stop, and I guess we can open for questions. Just to also say, though, I participated in the TensorFlow exchange that was organized in 2019, and then I didn't do a whole lot with deep learning stuff. I've only come out of the cold, to use that metaphor, fairly recently, of like saying, I wonder how I could get into this stuff. I'll confess to everybody that I still find some of the stuff with Earth Engine and Colab and Vertex AI a bit overwhelming of not knowing where to start and how to get in. But to say that, again, Tim and Biplav and others have put together some really great resources that are on this page that's linked on that previous slide. And also Tim and Biplav have put together a community where, every 2 weeks, and they just had a call yesterday with specialist from Development Seed who's working on a foundational model through Clay Foundation. But a month ago, Modu Mabai, again, who we see right here in the picture, was affiliated with Server West Africa, gave this really excellent talk about how in Senegal they're applying deep learning techniques, etc., to different problems that they've had. And again, I was just really blown away by how he just like everybody else who attended this exchange, but he really went like far and is going far with all that he learned at this exchange. And I feel kind of like, hey, I'm behind, which is why I'm only now starting with this ArcGIS stuff. But of course, again, acknowledging Tim and Biplav also for fielding some of the questions I've had. Kel, Nick Clinton, David Saag, Modu, Ujjwal Gandhi from Spatial Thoughts, who also puts a lot of material out there. I also threw some ideas to him about the slides that I was doing, and of course, recognizing Phoebe, our Africa Continental coordinator, recognizing Dr. Naruvbe for inviting me for this. And then I guess the last thing that I'd quickly mention is, again, I know that there are a number of QGIS plugins specific to deep learning. I'm not a Q person. I haven't looked into these things, but I would be interested to see if similar kind of end-to-end approach that can be done with ArcGIS could also be done with Q, which would make it completely open. Ujjwal, when I spoke to him about this, thought that another thing that could be done is just Colab and just using your local machine, that a lot of this stuff can be done without, say, having to use any of the credits from Google, et cetera, et cetera. But I guess I'll just, who like music, just say, 1994, I believe, the Cranberries put out an album called Everybody Else Is Doing It, Why Can't We? And I, just scratched that and said, everybody else is doing deep learning, why can't we? And so I'll leave it at that. And I know that folks have questions, et cetera. I guess let's open up for the discussion. And I know that Tim and others, also always looking at how we can tie the broader networks work specifically to West Africa. And I guess just queuing up Tim for one other thing. I know he's also working with everybody on a Geo AI strategy for the whole network. With that, I'll stop sharing. Over to, I guess, whomever has their hands up. Thank you.
Thank you very much, Emil. This is really interesting. So because of our time, I will call up Tim, and then Phoebe, and then Kidia, in that order. So let's go.
Perfect. Yeah, I just wanted to also highlight, I'm so glad that Emil shared the QGIS options, because we know there's cost limitations with some of the pathways we've talked about in the past with Google Earth Engine and the Google Cloud Platform. We know that landscape has changed quite a bit since 2019, and there are limitations that are very real. But I will also simultaneously mention that within the Servir Science Coordination Office and accessible to the Servir network, on Socrates, there are now 2 GPUs which can be leveraged for these type of activities. So we're now, I would say, we're moving into a new paradigm where these types of questions could be addressed with our in-house compute resources. And we're actively working within the Wendu service also on exploring the Science Cloud Managed environment, which is also a NASA space. So all that to be said, I think ultimately we're kind of in a funneling period right now where maybe all the resources aren't available to use these methods. But I think very soon we'll be on the outside of that aperture where we will be able to apply an array of different approaches, local GPUs, Socrates GPUs, working on the cloud. There's many, many options. So I think ultimately, don't let the lack of compute or these type of resources be a limitation, because I think we have an array of solutions there. So that's the one thing I wanted to mention. I also shared in the notes, Emil had put in the GeoAI working group website. We have, and I know I talked about this with Biplav on our presentation last year, but on the website we have resources for past talks, which include code, but then also we have a prerequisites page, which is really intended for capacity building. So you can go there, you can go through different courses, and you can really get the exposure on different models, different mechanisms, sort of what's happening and why you'd want to go down these pathways. And it's all independent learning. So you can just, take an hour, sit down, go through the course and learn as you go. I really enjoy that. And also There's even elements around there around glossaries and nomenclature, because personally, I'm an ecologist, and coming into this space, I found it really difficult to, Emil brought up the term, inference. Okay, well, I didn't really know what that was until I got into this space, and I would have been using prediction. Well, they're essentially the same thing. They're just computer scientists and statisticians have overlapping nomenclature. So this will allow you to sort of speak and understand maybe some of the existing terminology and map that to your knowledge as well, because again, it's the same methods, just different names that I found. And on that note, I know we're running along on time, but we have put together a large language model that lives on the website, and I've included it as a link. And if it doesn't work, do let me know. But the idea is to aggregate all of the knowledge that we've created over the past almost 6 years, with the videos, with the notebooks, with different material, and put that within a large language model for people to ask questions to. So if you have a particular question and you can't find it on the web, or you can't attend different working group meetings, you could go to this resource and ask your questions and trace back through the corpus of knowledge that we have what that answer might be. So we tested it with, why use VGG 19 versus VGG 16? And it can give you a definitive answer. And it may not be the answer, but it is an answer, right? So take that with a grain of salt. This is very much in beta, but it's something that we were trying to explore as making it more accessible for time zones and people's availability. And then the final thing I'll mention here, and get it over to other folks as well, is that, I'm so thrilled that Emil presented this inroad to deep learning, because again, that's a huge area of what we're trying to do with this working group. Allow this method to be more available to folks. And I just still want to echo that, if the problem that you're trying to address is linear in nature, stick with the classical machine learning approach. You'll save yourself a ton of effort. But if it ends up being nonlinear, then maybe that is where you want to go with deep learning. So there's still nonlinear algorithms like support vector machines that operate with a kernel that can provide you pretty good predictions with nonlinear features. But if at the end of the day you still want to improve, or you have a very specific use case, then neural networks is the direction you want to go. So, and I think we have a lot of resources to help folks in that space. So I always kind of end with these things that those approaches like random forest and even like linear regression are great, and they shouldn't be lost. But I just wanted to also say that if the problem is nonlinear, then maybe these are the right approaches to go for. So that's it for me, and I'll hand it over. I think Phoebe was next.
Yes, please. Thank you.
Can I ask Kedia to go first, so that just in case we run out of time, I can always access Emil and
No worries. I think mine will be very short, so you can, yeah.
Okay.
Go ahead, Phoebe.
Oh, you want me to go ahead?
That was it, yes.
Yeah.
Okay, good. All right. So, Emil, I wanted you to elaborate on the standard computer, because that means something else in the US and it means something else in Africa, because a standard computer for remote sensing for most of these institutions is really a heavy cost. So maybe just put specifications on that so that people are familiar with that. And also on the issue of GPU, like, if this is something that needs to sit, for instance, like within a server so that everybody else can be able to access it for their own use. My second question was in terms of the training demands for deep learning, because a lot of these approaches sometimes, you need a lot more training data than the standard classification methods. Then the third one was in regards to the minimum number of training epoch. Is there like a threshold that where you get a sweet result, as opposed to like having so many epochs? I know with based on what you presented, it sort of saturates when you put more than enough number of epochs. Then on other problematic classes, like on the urban areas, some epochs, some models use it very well, others don't. But it's sort of a problematic class to classify for most part, especially within Africa, because those areas are they're not homogeneous for most part of it. I think this would also relate to issues like crop type mapping, which is becoming more of an issue. Have you seen, for instance, this kind of methods providing sort of reliable results on things like crop type mapping? That's it. Thank you.
Sure. I guess, I don't know. And then maybe it's something that I need to do some additional experimentation with, but I was using, my wife's laptop, which is, a few years old. It does have an i7 processor, et cetera, but it doesn't have, say, the most RAM in the world, et cetera. So in my little table where I have all of my runs or whatever, and I hope, it might be difficult to see, but I have noted that, like, for instance, when I've now been testing with a computer that has a GPU and more RAM, the processes that would take, a few hours now take, 5 minutes roughly. But on this, say, older computer, again, it's 3 years old, but that was the one that I was using for this, benchmarking that I was showing. I have also tested on my even older computer that's 7 years old, but certain things weren't running. So, but I take your point, and maybe it's something that I have to kind of go back and do some additional tests regarding the number of training polygons question. I don't know the correct answer to your question. I've only been testing with the polygons that I do have, which aren't that many. And then regarding the epochs, again, I was going off of Esri themselves. I think they suggested you could test up to 100. I found, in terms of a quote unquote sweet spot for numbers, that 20 gives me similar visual outputs visually to what I'm getting for 50 epochs. But it seems that 50 does give us slightly better accuracy than doing only with 20. And then I liked Tim's explanation of how the epochs work, where you're passing data back and forth, etc. But of course, the more epochs you pick, the longer it's going to take to run. I did find, on this slower computer, that when I did for 20 epochs, I could get the results in 1 hour, versus for 50, it would extend the run to 2 hours, 2.5 hours. And so I think that's part of this. There are questions that I can't, honestly answer for you, because I'm still, kind of learning through these experiments. But I guess what I do find, kind of going back to something Tim said, I think that what the evidence is showing me is that we're getting slightly better classifications than we've been able to get using, just random forest, etc. Whether the amount of time that it takes to do some of these runs justifies the additional effort, I don't know. But maybe in a year's time I might have a different answer for you. But I appreciate the questions, Phoebe. And I guess lastly, just kind of going back to what Tim said, just because the world seems to be moving into this deep learning direction, I would hope too that on the West Africa side, that people say, hey, we will at least evaluate, whether this is worthwhile compared to the other methods that we've done. And then maybe when you evaluate it, you say, hey, for the problems that we have, it doesn't give us a much better result. Over. I hope that answers the question. And I guess over to Kiria.
Yeah, thank you, Emil.
Thank you very much. So I really truly appreciate we come together and to see new methods on ArcGIS and so on. Really, and also team, we are ready to contribute for the book for deep learning. And Emil, I like your last quotes, like deep learning should not be unattainable. So this is, I really share your thought. And we have here somehow, we are progressing towards that. So for example, in Survey West Africa, Galamsey is one of it. For example, it's based on deep learning, of course. And we are trying our best also in crop monitoring, for example. And on the surveyor session, we submit the abstracts on the crop monitoring. Of course, it's not based on computer vision, but it's based on vector-based analysis of deep learning. I mean, part of it. And now we are, for that submission, we did it, but now we are also doing on deep learning based on the PyTorch. So hopefully we are almost complete the workflows. Perhaps also we can share sometimes thoughts on based on our workflow. And I think it's the way, like, for example, if we get Socrates Plus GPU, that will be really wonderful. It's good news. And since we are now, it's on the virtual machine, it's great now, and that will be very good for us in the future. And I think today we missed some attendees from West Africa, including myself. Just I joined later on. But I like such, of course, we have the recording, Glory told me, and we'll share it to our West African colleagues, I think. So I wish if we have next time more, and Glory will invite you all to have such, inspirations on, especially on towards deep learning, So I think in future we have more, and we can share more on our workflows in future. And perhaps also we want to publish also that crop monitoring 17,000 polygons we have now, and we want to publish it on the TIFF record or GeoTIFF. Maybe we can explore where we can publish that data sets. Over. Thank you very much. And for Emil, I have a question. Just one question, because I joined later on. How is your data pipeline? Like how you convert, and like is it as Tensor, or how is your process method? Sorry, just come later on my question. Thank you.
So just to mention that ArcGIS provides you tools that then you have your training data in, say, as a polygon, a shapefile, or even as a TIFF. You have your satellite imagery as a TIFF. There's a tool that will then create that in the format that that can be read, I guess, as through TensorFlow, et cetera. So it takes your data, and then it makes these patches that then are used for the model training. And so it's a simplified process compared to if you're using TensorFlow with GEE and Colab, et cetera.
The records what you present in there. So it's our biggest challenge now, really, to process. To make ready the data as a little bit challenging here. So good to know. Sometimes such method.
I know we're over time, but I know a bunch of us are going to be at Sage. Tim will be at Sage. Phoebe will be at Sage. Glory, Kyria, yourself, etc. Maybe we could have this as a side discussion as appropriate in terms of data prep, the Socrates Plus stuff that Tim was talking about. Because again, as Tim said, West Africa is already paying for Socrates Plus. You have these GPU clusters. Like, why not take advantage of it? So yeah.
Thank you. Okay, thank you so much, everyone. These are really the explosive, very interesting discussion. And like been suggested now, two things. Maybe we will invite all of you again to this meeting. And then number two, it will also be nice if we meet at Sage and discuss some more. So because of time, I want to thank everyone for coming, and we are going to share this online, and we send you the link, and we will look forward to having you again some other time. Thank you. Have a great day, everyone.